Welcome to Tech at Lunch, the podcast that satisfies your hunger for all things tech while you enjoy your midday meal. So grab your sandwich, tune in, and let's dig in.
Hello, I'm Nick.
Hey, I'm John.
And, we're kind of back at you again. We have Champ with us. And, sorry we don't have Ed, the master of disaster.
Yeah.
He recently took a different position and, hopefully we get him back on the podcast with us. We got to get him freaking dialing in from another state.
Yep.
So,
Yep.
hopefully we could do that soon and, not have a little bit of craziness. You've had to listen to me for a little bit, sorry. It's painful. I know. And well, you got to listen to Tim a little bit when we were in Vegas, talking about SEMA. Sorry for the kind of big gaps in between. It doesn't make any sense to you, nor does it make any sense to me. So, but you know, we're John, and we're gonna have a conversation like we always do. And I don't know if you want to touch on anything of any of the other episodes you've heard before we went into this, or if you just want to kind of jump right into it.
Yeah. I mean, it was tough for me. I think that I really enjoyed you guys' trip to SEMA because it's always cool to see it. It's an entire different world that I didn't know it was there. I mean, you had to explain what SEMA was to me when you first started talking about um, the convention. I'm assuming
Hmm.
it's an event.
Yeah, a
But
little bit of
yeah,
mixture.
the rabbit hole was deeper than I thought.
Yeah.
Yeah, no, I really enjoy the concept of additive kind of branching out into automotive. I think it's a natural step, and a lot of people think that's, not a way to build end products, but a lot of it's not supposed to be the only way that you produce or build, and it's supposed to, facilitate the growth in any industry, right? You showed me a few videos of some of the custom cars where they built a bunch of 3D printed pieces of it and have a like a pretty much a souped up race car. Um, we have space rockets and things like that, so like I know that it's durable enough to do that, but never have I seen any of the products, So it's cool to see. I really enjoyed the SEMA pieces, and if you guys aren't familiar, you guys should check it out as well because if you're ever a car person or anything like that, it's got something for you, right? And then especially with us because I mean I focus a lot on the additive side of things, but there's a lot of potential in kind of in the rapid prototyping that comes with additive, which means that some of those parts that are more antique and things like that, it gives you a lot more availability to recreate um, a lot of classics.
Hmm.
So I think like showing the usability and the viability of additive is cool that it would be shown at SEMA. I don't know how many uh, manufacturers would you say you saw there?
From the additive side, that's the funny part because your biggest additive manufacturer who was actually on site was HP. Um,
Hmm.
so they were on site with their printers. You did have a couple, people that were showing a lot of the 3D scanning technology. Um, you did have Haas CNC there with the CNC machines, of course. Um, but the funny part is a lot of times it's the engineers that you see that you talk to, like some of the companies. Like I walked by one car and I sat there and kind of stared at it for a minute and I said, well, that something's not right here. I said, and I'm pretty good judge of character when it comes down to like an older Impala. I looked at it and they're building a race car out of it, and I said, "Oh, well, this is interesting." He goes, "Yeah, yeah, we do all 100% R&D with 3D printers. We have metal additive we have metal 3D printers. We have scanners. We have all of that, and they build their car 100% in CAD and with small level additive manufacturing before they go into full force, full prototype. And this is just for a customer part."
Yeah, I mean it's impressive. I mean you can reverse engineer so much with just the scanners, and I think that's more of the piece that you're saying that you saw prevalent, but we're getting to a point where manufacturing is going to be able to produce so many more things that are just in people's imaginations. Period.
Yeah, the line's
So
blurred, you know,
yeah.
and it's like the guys from if you took a look on the Vulcanar Technology Solutions channel, you'd see that we got invited to go see the AC cars reveal through Tremec Electrified GT and Tremec transmissions. And we had a really good conversation with AC cars, with a head engineer of AC cars that was over from the UK. And we really had a conversation about how they used additive to rebuild parts and stuff like that for the GT cars that they were building. If you know anything about AC cars, AC is also the Cobra car, which is the granddaddy of the Shelby Cobra. Um, so that's where he got the idea from. But the thing is they used additive and they used, scanning and stuff like that to really build out the vehicle before they finalized it. You also have people that were 3D printing like knuckles for their suspension geometry was 3D printed. You have guys who are doing, and this is where we'll really get into this in a minute, is you'll get into, the guys who are making the steering knuckles. They're making suspension parts in 3D with a 3D printer or metal 3D printer.
Hmm.
Exhaust tubing. That's what you were talking about that I showed you.
Yeah, and
Um,
uh,
turbo piping. If you think about it, if you think about the pressures and stuff like that, that has to freaking take into account.
yeah, I think there was something because I was investigating. So I've been going to grad school for a little bit here. It's been kind of daunting, honestly, trying to do it with a full-time job. So I don't envy anyone. But at one of the things that I had to do over the course of my semester was my metallic materials class. We had a project where we needed to propose some type of study or some type of method for printing or additive manufacturing method that hadn't didn't get touched on. It's not one of the core like 6 or 7 processes, and we had to explain that to the class, or we needed to make something. Ceramic brakes
Ooh.
was something that came up quite a bit because
Hmm.
like think about how often people go through brake pads, think about how many times you hear it screech. Like if we could manufacture those like in a location, I think maybe a company like Discount Tire might benefit or something like that.
Yeah.
We replace your tires, we'll look at your brakes too, and we can print them here on site. I'm gonna be honest with you, Discount Tire, come and see me if you wanna, we could figure this out. But
You may get a
but
visit from EBC
yeah,
Brakes
right.
before you get a visit from them.
Yeah, I was just saying. But you see the potential. This was one of the things. I think there's companies making ceramic rims and
Hmm.
like the entire tire, but not necessarily like um, the brake pads. I mean, there's a lot of potential in a lot of different uh, portions of additive, but oh, I mean automotive. But additive really solves a lot of problems that you didn't realize you had too.
Yeah, exactly. And the thing is ever since we coming back from SEMA, we've actually started. We're really getting the channel up off the ground here a little bit. Is the Vulcanar Motorsports. We have a new channel called Vulcanar Motorsports, and we have a new community just for that. Um, but and that's what was something we'll really be touching on is how do we use additive in motorsports? How do we use the additive to support a vehicle build? How do we design, prototype, and test the materials that we need to build a vehicle, say in the garage or in a shop or something like that, using scanning and printing and techniques, and then eventually getting these parts CNC'd. So guess what? You don't have to worry about that anymore, or you make them out of sheet metal. So but that's something that
Hmm.
we're going to be definitely covering there, and I think as we get into that, this is kind of where we're going to segue into today's topic. Um, and that's going to be testing and material validation. Um,
Hmm.
because I think we can definitely segue into that, because especially when you start talking about the fact that, like automotive parts and stuff, that you have crush factor.
Mhm.
You have shear forces, you have torque plus angle for certain things. I definitely don't ever really want to rely on my 3D printing my safety bolts, but anything's plausible.
Well, here's the thing. A lot of we've also been very like worried about. I think we've expressed a general concern about the like jumping to saying my product or my end model is industrial grade. Like, and what does industrial grade mean really?
Yeah.
So at the end of the day, you, there's ways that you could prove to me that like you have like for instance I'll harken it back to when we're 3D printing for the first time. There are ways you can prove to me that your bed is level. There are ways that you can prove to me that your print temperature is optimal. There are ways that you can prove. We covered it when the calibration prints, right?
Hmm.
Like we say use these prints so that your printer will be able to produce at peak value. But why can't we then switch that same ideal to say uh, perform enough tests to validate a material can maintain this strength. Like I learned a lot of these tests that I'm gonna probably go over a little bit later um, in class, but at the end of the day, these tests make a lot of sense. And you've honestly, Nick, you've seen these tests in action,
Hmm.
or at least two of them you've seen in action. Um, So we do are they before we go too deep, is there any like standard tests that we did without even thinking about the scientific side? Like we just went into um like we put the probe on so we stopped having to think about the bed level,
Right.
right? So we had to do a lot of things. I mean, what is the benchy for, right?
Exactly.
Like it
Or the
does
Voron
everything.
block. I'm looking
Mm.
at one of those sitting right in front of me.
Yeah.
And then of course you start getting into, hey, if I'm gonna use this for this, let me do the bend test. Maybe print a 1 layer or 2 layer bend test to see what type of, calibration I need for my layer thickness and stuff like that.
Yeah.
So yeah, you're right. We've used a lot of, maybe not like ISO level testing, um, but definitely some testing where it's like, oh, okay, well, I didn't, you don't think that it's validation testing. You don't think that it's, what it is, because you're not documenting anything. And
Right? Is it testing if you're not documenting? I
that's what
still
I was
think
getting.
so.
That's what I was getting ready to get into. Some people don't think it is. Some people don't think that, hey, just because I don't document this shit doesn't mean that it wasn't actually tested, because everybody wants a paper trail.
Yeah.
Not everything requires paper trail. It's like, cool. I don't have to give you, like, for example, if I'm doing, powder bed fusion, I don't need to give you my micron bed level, my level amount. It's going to be the same no matter what. So,
Yeah.
is that really required on ISO form? Maybe not.
Was so So to be honest with you, it's a difference of like the school. So a couple schools of thought here. So the documentation is a way to ultimately validate and then never have to do it again.
Right.
So if it's something that you're doing in a constant process, like if you're never gonna do with this material again, like I think that it doesn't make sense to constantly write everything down. You make the decision, move on to the product that you want, and then you make your measurements, save your config. I think at the end of the day, we're saving our config. That's our measurements that we're expecting, and I'll be honest with you. If I lost my settings and had to go back to default, I have to start and do all the tests over again. However, if I save those tests, backed them up somehow, I would be able to upload them easier. So I think about it like that as a system of backups, so I don't have to waste my time again.
Hmm.
But if it's something that you're repetitively doing anyways, like consistently making one print that's the only print, and it's I mean it's what's going, like for instance the brake pads, it's totally okay. I think there's what is it, like a certain number of quality or percent quality
Yeah,
that
like
you can.
10%.
Yeah, so some like it's there is room for error, but I it's tough. The doing all of the data science is, it takes away from the essence of the testing
Yeah,
sometimes.
of what it is.
Yeah, so it because it pulls you through another process of you just trying to document your process. And I mean, I think it's worthwhile, but that's why I'm saying there's one school of thought is the documentation is the only way to go because it's how you prove every single
Hmm.
thing. And those are the same people that are like math is fact, and that's the only things are because of math. And then there's the other side is like, well, I found out that you could put a fire out by putting a cup on top of this flame, and how'd you find that out? I did like 17 different ways to try to put it out, and this is the only one that worked.
Yeah, exactly. And
It's definitely trial and error.
it's and somebody who comes from QA, the IT
Hmm.
side of QA, it's one of those things where it's like everybody's like, oh, document this time. You're building your specification. However, how do you know that specification is valid until you've broken it like 16 different times? If you don't continuously, test your specification, you'll never find out exactly if that specification is what's correct or not. However, if it's the only specification you use, you don't have to retest your specification every time. And like you said, it takes the essence away from, what is testing, what is validation, and what is, just the fun in it. Because,
Yeah.
that's why sometimes I think that you're always going to find the QA department that's not involved in the actual production, nor are they involved in the actual specification process of the machine. Okay, cool, I can hit this tolerance. Cool, have fun. You know, and the engineers take the rest. Why? Because some of y'all out there who work in the, in validation and IV and V and stuff like that, y'all are some grumpy folks. Um,
Yeah.
eh,
Repetitiveness makes you go crazy after a while.
right, but it's also
Tedious.
the data, and the only thing you see is numbers. Like I love numbers. I don't have a problem with it. However, I don't need somebody to tell me that 2 plus 2 is 4 when I can look at the product and the product don't work.
Yeah, that's true. I mean, there is a such thing as having too small a vision or too big a vision. I
Right.
mean, like if you're saying that and the end product, like to me, you have a production mind. You just the product is the proof. The proof is in the pudding, pretty much, right?
Yeah.
And to be honest with you, for most part, yeah, I mean that's how we put people on the moon. The proof is he's on the moon.
Yeah.
Like that's
It
I
worked.
mean, but those guys also had people with them that were like you said, cool, calculated. They wrote everything down, but they were a little bit more strict because you have to be strict to
Right.
want to do that much data. You have to be that disciplined in just forcing yourself or see the beauty in the numbers where some people are not looking at the numbers, they're looking at that's a rocket.
Yeah. Look at
So
Dr. Von Braun, and his team when they came up with that thing, and then look at the polar opposite to what is Dr. Von Braun. And look at Elon Musk.
yeah.
And then you look at what is I guess you could say the new age Von Braun, which is the guys with Rocket Lab and with all those other guys who are test and stuff like that. While SpaceX is, yeah, let's fly it, see what happens. We need the data.
Hey, it's gonna blow up eventually. Just make sure no one's on the ship.
Right. It's I want to make it to Mars. I don't end up as a crater. And it's one of those things. But I think that sometimes you get the time of when your data guys and your product guys and your engineers they become one, and they become this this testing and validation organization that kind of go, ooh, okay, well, this makes sense, and everybody has fun. It's cool. Let's test this till it breaks. You got the engineer digging into the data while the test guy goes, let's give it full throttle. You know,
Yeah. Yeah, it's hard to bridge the gap between the two as well. I mean, to be honest with you, you want everybody wants to I mean, you want instant gratification. It's tough. not to see the products in the first few attempts.
Hmm.
But I think like think about let's compare two things even. Yeah, I like the Musk analogy. Like so, look at SpaceX. How many launches did it take for them to get Starship into orbit
What,
in one piece?
3?
I was saying one piece. And now let's look at NASA. The SLS has made it into the air in how many?
1.
So, yeah, I think that's a small example, but if you compare how many example or how many attempts, like let's say, and I don't, and this is not to be a detractor from these other countries, but like India, like China's,
Oh boy.
Japan, like these are big space agencies still,
Hmm.
but how many times did it take them to do what NASA did?
They still haven't made it half of them there.
Some of them still haven't made it, right? I mean, if you ask Japan, their lander's upside down, but it's there.
Yeah, it's all but that's the thing. It's like, what is it a success, or is it a failure?
I still think it's all, yeah. See, and that's the tough part is how you view it, because I think it's all still successful. Because guess what? It's all testing, and it's all like the theme is the validation of what you made and the work that you put into it.
Right.
So I think before we get into like too much, I wanna touch on a couple of these. I'm gonna try to be brief on them, anyways. But like that should be the essence of what this testing is for. Like, don't think about the tests as a way for, you know, is the only way to validate that you've got a useful print.
Oh yeah,
It's not.
you definitely have to,
Or product, yeah.
document, and stuff like that. But repetitive attempts, making sure it's perfect, what you want, make sure it matches your CAD. Have a little bit of
Hmm.
fun with it. And it's the theory of, does it bend and break, or does it just bend?
Hmm.
If it bends, then it's still somewhat viable. It does what you want it to do, technically. Does it bend back? Yeah. Um, you
Yeah,
know,
well, listen, entropy, sometimes things don't go back.
right. Or it's aluminum and you work hard in it. But the thing is, it's there. More people put testing into their product without even knowing they're doing it,
Hmm.
and you kind of see that because, especially like when somebody goes and starts using ABS for the first time, oh, this will work. Okay, well, what are we gonna use it for? Well, if I set it outside, will it change colors? Or then it's like the guys who figured out that you can use alcohol to smooth out ASA.
Now, he just left alcohol out, and that's what happened.
Yeah, yeah, that's probably what happened. But
I mean,
technically,
yeah,
he's
that's
gonna
the
say he was testing for something. He
yeah.
was doing, some material testing to see what he could do with it.
I'd say 50% of inventions are accidental.
Yeah, probably more than that. But I'll,
Yep.
I'll give you the 50%. You know,
Wow.
I'd say half the time it's what the hell. Is usually how an invention comes about, and you're like, oh, well, that worked. But then you go back and test it and validate it and go, wow, this really did work.
Yeah, like, oh shit. Like, how did I get that so right?
Right. If you think about it, look at the guys who developed chromium. You
Yeah, I
know,
mean, honestly, there's a lot of people stumbling backwards into some things, and it's, I mean, it's good for what it's worth. I think that you can, if you have limited resources, right? It makes sense that you can't, send a rocket to the moon,
hmm
right? It makes sense that you can't, land a rocket back in the place that you launched it. These are very difficult, and you need a vast amount of money to be able to fail,
right.
right? Does failure mean critical? Does failure mean, oh, just that's attempted, failed, we can retry? I think at the end of the day, if you want to limit the amount that you're spending, then it makes sense to probably conduct some kind of focused specific tests before you do your end product. And I think this is honestly not to say these specific ways, but this is honestly most likely how NASA was able to get it right in one launch, right?
Yeah.
Is that, and I wouldn't even say they landed on the moon in one launch. What did it take, like three?
Yes. Yeah. For Apollo to land on the moon, it was Yeah, well, technically, yeah.
Because you should count the full launches, not any of the test launches or anything like
Yeah,
that.
it
Like,
was 3 orbital moon launches before Apollo 11 was given the go to land. And that was, in orbit testing for certain things and stuff like that. It's also, being able to use, the other launches to test spacesuits, to test the material that spacesuits are being made out of. And because the thing is space is the ultimate laboratory.
hmm
And, between space and heat and also the Arctic are your three biggest laboratories for any type of material testing you can ever think you want to do. You know, because the only thing you can do here, I guess at your, home or in an organization where you don't have that type of material is, well, design a test that kind of mirrors that environment.
hmm
And if you think about that's how do you think we came up with what it was it nylon 12 with carbon fiber?
Yeah, I mean NASA's still developing alloys because they have reasons to use it. I mean, think about nitinol. Nitinol is
Yeah.
is a metal that um it's a smart metal. It remembers memory metal. Like you, it's crazy to see. It's what the wheels of the rover are made out of. Because if you apply a little bit of heat to it, it goes back to its original form.
Yeah. And just think that material was probably made by accident.
Yeah, yeah. I mean, trying to do something else, and then you notice, oh, hold on a second, I might have something here.
And yeah, how do you think they developed the car?
One guy was riding a horse one day, and he was like, "What if I put wheels on this?"
Yeah, and got rid of this thing that breathes and put a
Yeah,
motor there.
yeah. We don't have to slow down ever.
And
But
technically,
yeah,
all an
no.
engine does is suck, bang, blow.
So that's, I mean, like that's these tests that like I speak on is there's a standard. Um, ATSM and ISO. These are standard testing models that several scientific, I would say, or organizations and you know academic bodies agreed that this is how we could test to validate certain material properties. And because like you need what's the measuring stick, right? And who decides what we're measuring? If everyone agrees, then it makes sense. Uh, Mitsubishi actually gave me a great example of the geometry. Like, so think about like if every printer made a wishbone, would you would be able to test the break strength of pulling on both sides and say, okay, well, which material did the best? And if you think about that and you change the model to certain types, you can induce a whole bunch of different changes or tests. So there's tests on like, so how much would it take for me to pull this apart? So you talk about shear and break. So this actually has an ultimate tensile strength, and you can have something like, think about snapping a stick, right?
Hmm.
You apply a force in one spot, and then you break it into two pieces. That could be tested in the same way. Or your material can be tested in the same way. Like we do these tests like unknowingly, like you said before, all the time.
Yeah,
So this flex strength, that you can measure how much energy or foot pounds or however you want to measure it took to break this model. And once you document those things, you can kind of take those, and if you do them, you know certain number of times, you can actually graph something. And to be honest with you, the less samples or specimens you have, the less of a chance that you have to see what an actual curve or performance would look like, right? And
yeah.
so this is where both worlds kind of blend into one.
And and with that, I think that, like you said, creating the specimens. I really think that, like if you buy filament, like say you buy filament from the same manufacturer over and over and over again, like you are buying, batched filament. So you're buying, say 10 rolls of this batch 1 month, and the next month you buy 10 rolls of the batch that they made that month. You should be doing, or I think you should at least be doing those type of shear testing, that type of strength and rigidity testing. It doesn't take much to print the test bracket. to put on one of those machines. So you can actually, like you said, graph out and collect the data for every single batch of filament that you're using. So you kind of know, did your properties change based on, environmental factors that was going on in the plant at that time? Or, is there an issue with the actual material that you have? You're not saying do
Yeah.
it every roll. If you do it every roll, then you're really going above and beyond. Every time you change a roll, do it, but that's the only problem at that point is now you've induced yourself into the process problem where if you don't have the filament dried enough or if you don't have the filament stored correctly, you're going to induce failure points.
Yeah. Yeah, and I think that that's the what you measure it off of, right? You measure it off of those failure points, and that's how you can. I mean, you can save a lot of time. But at the end of the day, what do you have time? First off, that's one question. If you don't have the time to do all these things, then you can, I mean, cross your fingers and hope that your material will last. But also, you you leave yourself up to needing more trial and error.
Hmm.
So, like with a few of these, you might even be able to do a couple tests and then decide on a material as opposed to try all the materials. Now, if you can try all the materials, like we were saying before, if money's not a problem, then yeah, have
Yeah,
at it.
let it rip. And it's like I watched my own, one of the guys on YouTube. He explains how to build a print farm because I'm always interested in seeing how people do their businesses and stuff like that, especially when it comes down to additive because everybody does it differently. No one's ever going to do it the same. So, like, he realized he's having issues with his PLA, which always confuses me. But he's using Bamboo Labs. He's having issues with his PLA, and what he does is he automatically, when he gets his PLA in, he dries his PLA before he puts it on the shelf for storage. Okay.
Yeah.
Sounds kind of weird because it's like, okay, well, why wouldn't you just dry it before you use it? Well, he keeps his shop, the shop he's in, he has three industrial dehumidifiers running 24 by 7, 365 degrees, keeping the inside of his shop at about a 20% relative humidity. So it is dry, but still with enough humidity to make sure things stay flexible and pliable, and you're not walking, in there feeling like you just, got sucker punched by, the sand gods.
Yeah, it's tough. I mean, humidity is can be a pain, but can also feel refreshing.
Yeah, but testing and having that as a variable,
It
especially
hurts.
when doing your material validation, can be kind of a pain in the
Yeah,
ass.
you want to limit your variables. I mean, it makes life easier. Like to be honest with you, you can test to see a lot better if you eliminate your variables. I mean, I think about temperature testing too, and how did people validate what temperature causes like plastic deformation or things like
Hmm.
that, and how do you do that? You put a specimen in a sample enclosure at a vacuum, and then slowly change the temperature there. I mean, it's just something that like there's a whole bunch of ways that you can kind of set something up to test for, like impact testing. How do we impact test vans now or cars? You just call it crash testing. You smash that thing,
Yeah.
but there's ways that you don't have to expend, as much money. It's just since there's so much manipulation of the body and the sheet metal for a van, it makes sense to retest, right? Because you're taking parts apart and attaching them back together. But if you did one print and had a certain type of test, I'm sure if anybody watched MythBusters, they've seen this impact test before. You notch it, you set it down, you drop a hammer from an angle, and it goes around and smacks it with just the weight of the hammer. And the higher you pick up the hammer, the more force that you're applying.
Hmm.
So yeah, more impact. I mean, at the end of the day, like you've done this before. If you've ever broken something by just hitting it enough times, you're like, I think I could break that.
Yeah, and the thing is, if you think about it, with a little microcontroller, you can automate 95% of your like impact testing, stretch testing, shear force testing, and actually collect more data by using like, the was the force sensors and impact sensors and speed sensors and stuff like that because at that point you put on that hammer, you put a freaking speed sensor on it, how fast it's moving, and you know what it'll take.
Hmm.
ish. You know.
You do what you can. I mean, some problems. Yeah, if you know your failure points, then you know what you need to adjust your process parameters. I think, depending on the type of print or the type of method or the type of whatever you're doing testing, if you can adequately say, well, this part's going to be outside, so temperature needs to be a main parameter that I test for. Okay, well this is going to be under high load. Okay, I should test for this right here, and then you can make an educated guess and then do trial and error from there. And I
Hmm.
think that's a healthy median where a lot of validation lives, because then you can probably I mean, if you make an educated guess, you might be able to get there much quicker.
And I can agree with that and wholeheartedly agree with that because you have to also test a failure. You know, testing to that'll work. Is not a failure point because like if you said okay cool I need to build this piece like you said put it outside the weather's an issue if I put out there for it's only designed to sit outside for 2 hours a day. Okay, so you put it in your environment for 2 hours a day, you pull it back out. Yes, cool. Your initial specification passed. However, you need to leave it in those conditions until something fails. Because, or,
How will you
act
know when you need to change it or if you need to change it?
right.
So.
And you can update the spec, good till. And now even if it's like, hey, does not like being, go under impact after sitting outside for 4 hours a day. Okay, well, that's a new, variable to add to the mix, and that slowly but surely, like you said, adds to your data points. But the thing is always test a failure. Don't test to the requirement.
Yeah, it just depends. I mean, honestly, if you're doing this for yourself, I mean, it is what it is. You should be driving for more knowledge or to fully validate. I mean, if you're limited in money, you can only make certain models, and yeah, I mean, you're gonna have to make some hard choices and stuff like that. So I think that yeah, it's if you only have one or two attempts, you should test more, and that's why I suggest the smaller tests
Mm,
that are also standard, because if you record enough of them, you can prove as well. And honestly, it's something that will give you peace of mind, so that you don't have to worry if, oh, hopefully it's not going to work, or hopefully it's going to work, or if it's not going to work, then I don't have a way to do it again. You should just be able to make the decision off of some of these tests. And that's why, like, for a big print I've done before, I do, a box, I'll do for a layer print in the center. Okay, my center's good. I'll do squares on the outside. Okay, my entire bed level is good, even if I have the computer validating. So I know that it's good to go. We've validated in two forms, with my clipper and in my firmware and my manual uh, leveling, and then I can ensure that this 58-hour print is going to probably do well, but I still need to check on it throughout.
right.
So like if I would just go up to the printer and say, oh, well, I think this is good because it worked the one time, and send it, you're probably going to end up with a problem.
Yeah, more than
You
likely.
should, yeah. Updates and checks are honestly probably what saves a lot of, because you could attack it from both angles.
Yeah, and never think that the same filament is exactly the same from manufacturer to manufacturer ever. Um,
Yeah.
ABS from one location is not the same as ABS from another location. Um, PLA is definitely not the same from one location to another. Believe me, I think we have stories on which ones not to pick. Um, but like you mentioned, if you're doing like the swing validations, you're doing impact testing, you're doing stretch validation, you're doing bin testing. If you're printing one bar to do your testing with, print more. You could, print six of them, and then go into but you own your G code and change the infill amount of each and every single one. So you can have the different infills and stuff like that to test if you're doing that. If you're doing the impact testing and stuff like that. The filament is not going to change price once you've already bought it. And if you have to use an entire roll for your product, you've already failed. because you need to be able to test it first before you put out product. So now you have to at least have two rolls but you're not going to use that much filament anyways to do testing. So
Yeah, I mean the end, I guess the end um, idea is that you should consider your end result.
mhm.
I mean, it's tough to just go right at it. You should consider it at least a little bit, and then you can start your process of testing and validation. But if you just go at it without thinking or without, let's say, honestly budgeting, then I think at this point, is it considered a project or considered a hobby?
Right.
So, yeah,
Yeah.
I mean, as far as testing goes, I think there's a lot that can be said for how much has been proven and documented already. But I also think that there's always going to be new tests that get adjusted and things like that. Different applications call for different tests. Like if I'm using the same material but in a screw form or some other fashion, I would assume that there would be a different test that you could do to validate it works as a screw after you've printed it.
Yeah.
Or even if you have build direction differences, like you can say, okay, well this build directions um, is better than another, and that's how you can kind of get towards more of a concrete answer. But without those proofs, like it's hard to convince someone if they haven't seen it with you or did the tests with you.
Makes sense. Now, explain to, everybody, just, I guess you'd say, in a short-term version, we don't need, not the farmer's almanac version. Um, the testing and validation plan that you came up with for your school project for the bone screw.
Oh, for the bone screw? Okay, so I used some of the standard testing I've already kind of talked about. Uh, so for me, it was we had to. So let me give you the basics of what the project was. So I either teach the class about a process that we didn't cover, or I pick an area of study I thought was interesting to make an end product and apply additive to that process to change. How did my process change affect that end product, and for better or for worse even. And I chose that side. So I chose a specific metal. It's a titanium, tungsten, zinc, and magnesium. Now I'm going to be very honest with you. There's a lot of differences that I would have to review, thinking about how these metals reacted and what percentages they had to be to mix together. But I noted that as an assumption. I said that I assume that these would work well together because I have instances of each of them being used in a bone screw of some type. And then my goal was to create bone screws that are reabsorbable so I could avoid placing medical inserts or um, um needing a second surgery. And honestly, the goal was for less pain in the screw, and it'll absorb back into you. These metals, like zinc and magnesium, are in everybody's body already. It's just at a certain point you have to consider, would you have to limit the intake because this is being absorbed in a screw or something like that. So what I did for the testing though, so the goal is simple. I mean, the goal is here's a new metal. I have to adjust my process to be able to combine these four metals, and then I set a percentage of each content, and then I just said I need to validate that it has structural integrity, so structural strength. I had a ATSM standard, which is similar to one that we talked about before, of like just think about, uh, picture uh, uh, a stick that you just broke in half, and that's kind of how you test break and things like that. But there's also a standard for screws, especially bone screws in the medical industry, specifically because they have to be inserted into a person. There, in order for it to get approval, it needed much more thorough testing. So there's a test for bone screws in general. I had a lot of examples of titanium where the the important parameters was your axial strength, your torque, pretty much on the screw, to get it to go into the bone, the removal strength in case you had to remove the screw at any point, and degrade time. So degrade time is something that's a little bit difficult to measure, of course, unless you're screwing it into someone and then a patient and then coming back later to see what it's like when you replaced it. And unfortunately, I didn't go that deep. But what I was able to validate is that there's been tests with um, it's called osteogenesis or bone generation,
Hmm.
so bone regrowth, uh, with magnesium and zinc already. And titanium already had examples in those bone screws. For instance, the example I used was ACL repairs. Like they take a tendon from your hamstring, replace your ACL in the place that where it tore, and then they screw it in with a bone screw that is biodegradable, or bioabsorbable. There's a whole bunch of different terms, that they used in a lot of the papers. But at the end of the day, I used all of these were plastics. So there's like a combination of PLA and a few other things. So you're putting plastic into your bone, and in my opinion, the strength of the plastic isn't what I'm looking for in the strength of the bone, right? I want to maintain the highest bone strength with the lowest weight, while also having the screw be able to be absorbed into the bone, right? More precisely. It's a little bit difficult to do testing for if it would be bioabsorbed better, or accepted. I kind of drew the line at, like, would it be toxic to the body, right? So we call it cytotoxicity test. So they take body, I believe it might have been stem cells. They put it in a petri dish. They have three different types: direct exposure, indirect exposure, and then, like, I can't remember the third off the top of my head. Um, I think it was submersion,
Hmm.
but I don't want to I don't want to quote that. It doesn't sound quite right. But there was three tests that you did, and you could judge the cell growth, and if the cells died on a scale that you would kind of compare the different amounts. I had different percentages of each metal in each bone screw, three samples, and you could say, okay, well, this sample did better in this case because there was less um, cell death. That was the way that I was able to validate it could be bioabsorbable. Not necessarily going to work on the first try, but like it's a start to point me in a direction, especially in a realm that's so sensitive, because I mean, these are people's lives that you're messing with, right? So you don't want to put a screw that's not fully vetted into someone's implant. And then of course I did the mechanical strength tests. Like, I need to make sure that this is going to withstand, like, all of the same rigor that a bone would in the same position, right? So I was able to do those things, and that's how I validated those that material would potentially be viable in that realm. And that's kind of where it started. And that's all. I really only had 5 minutes to present, but I had to put all that into a quick explanation, and then write a paper on it to show that these tests are viable, that this material was possible, that I could make this if I had the uh, resources, right? If I had each of these powders and a gas atomization machine, and I used the powder bed fusion machine. If I had all of these machines on hand and all the materials, then I could try this. It doesn't mean it's going to work, but I have a plan.
Yeah, and
And
I've
that was,
done.
I think, the goal of because the whole course we did reviews on scientific papers that was just a bunch of other papers compiled, and an assumption made and a test ran. And, like, when you start viewing all the scientific papers like that, that's pretty much what it is. I have an idea. I want to test it. Has anyone tested things similar to this? Any of the materials? Any of the properties? Okay. So, I mean, I've said it a few times in the podcast, like, you stand on the shoulders of giants. So you don't have to do as much work. You stand on their tests, and then you build upon it. And I mean, that's honestly how we've gotten most of the things manufactured in life that we do now. So, I mean, yeah, I don't want to keep going too deep into it, because I think that's majority of what the project was about. But At the end of the day, that's the essence of what, how I was able to validate the whole project hinged heavily on the testing and validation, or how did I think that my process, or why did I think my process would work? Because other people conducted these tests and I'm comparing notes.
Yeah, and
So,
that type of project for me is absolutely it's insane. It's actually really cool because I think that
mhm,
any type of using technology to better human life, especially using additive to better human life,
yeah,
and to not have to go back in for another surgery
yeah,
is a game changer, not impacting human health, supporting human health at the same exact process. That stuff that is, game changing, that's, next generational type of stuff that we're dealing with. And, it's for me, that shows kind of exactly what we're talking about with the testing and material validation side of the house. And that's why, I kind of wanted you to explain that so people kind of understand of why we're making such a big deal
mhm,
of, what is testing, what is validation, what is IV&V, um, if you have to do an IV&V, um, what is that type of stuff that you're dealing with, um, and it's just one of those things that isn't just relevant, and that type of test and plan isn't just relevant for medical. It's relevant for structural issues. It's relevant for any type of motorsports that you're building or using, additive manufacturing to build parts, pieces, things, and trinkets for. Um, it's just, it's awesome to me, what I think. But, and I'm sure we'll do an entire episode one of these days on additive manufacturing education and really kind of dig into how colleges, for example, are building this additive manufacturing side, for example, or also on top of that, like my doctoral thesis that I've kind of got the topic approved on is that I'll be looking at adding 3D printers and robotics to education and how that will change the way we do things. That's teaching kids how to plan, that's teaching kids how to do, testing and validation, from a young age. So they kind of have that idea all the way through of, hey, guess what? This may be a career I want to get into. However, we need more companies to start making and generating entry level additive manufacturing careers, for people to get interested in this without having to go through, 4-year universities where they can just go through tech school or something like that. But
yeah. I mean, some of it takes time, and I mean, some people learn faster than others.
yeah,
I don't want to limit anybody because this semester was my first kind of jump in, and it was a slap in the face. Um, Going back into school after taking about 4 or 5 years off, I think that um, the main concept of wanting to learn is something that stuck with me. So yeah, I mean, your growth is yours. So like, as long as you're happy with where you're at, I think that that's something that can be touted. But at the end of the day, if you're trying to drive a little bit of that knowledge, yeah, I think that you need a bit of a direction. And school gives direction to some people who may be smart or like inquisitive, but don't really have a direction. I think that it's something that's pretty difficult to judge when you come out of high school or even middle school. Like I wasn't thinking about um, school really. I mean, school was easy, so I was able to move on and do other things that I enjoyed, have fun with my friends, go play baseball or something, and at the end of the day, I think it's important. You learn in everything that you do in life, anyways. So if you keep a methodic way about it, like I think that you'll see the dividends like come, um, you know, quite a bit, and really pay off.
yeah, everything goes full circle. And
Wow, wow.
definitely, continuous learning is something we've always preached. But and that's something that we want people to do. However, I think we'll end it on that point. And from my side, I say thank you, for everybody who's listened to us on, all platforms. I'm trying to get the numbers now to see, where we're at because last time I checked, we're moving on along, and we've definitely hit the numbers we kind of want to be at, and we couldn't be happier. We couldn't be, had more fun doing this. 30, what, 3,360 people have listened to us, and we keep growing and growing and growing. And, the thing is, I hope everybody's enjoying it. I really do. We probably get more of a kick out of talking, running our mouths, talking about random stuff than, hopefully y'all enjoy it. If you keep listening to it, I hope you do. Um, if not, you need a better hobby. Um, but, and I
Pretty
guarantee you,
far in the podcast to be uninterested.
right. I'm sure we appreciate y'all more than you appreciate us.
Oh yeah.
But and the thing is, I just want to say thank you to every single person who's listened to us. Go out there, check out Vulcanar Technology Solutions on everything. Go take a look at Vulcanar Motorsports. Go follow us on, Instagram, Facebook. The YouTubes. Also, we'll have our links in the description below, of the podcast, so you guys can go and find that type of stuff. Go take a look at the blog, the blog.vulcanar.com, and you'll also have a Vulcanar Motorsports blog now too, kind of where we're kind of talking about the additive side and also the engineering side and motorsports, where we're trying to get kids interested and motorsports again through STEM education, and also try to get kids interested in STEM education through motorsports, because we want to save our racetracks. We're kind of at that point these days. Have a little bit of fun, find a project to do. But go take a look at that. Go take a look at Printed Heritage, for some of that stuff. We will be, come out with some new merch here soon to go along with the Vulcanar Motorsports, so that stuff is coming. We hope to see you at Rapid next year. At SEMA, we'll be there. And hopefully at a couple other things. You may see us at, Hot Rod Power Tour. You may see us on some other things that we're doing. Come check us out if you see us at a Formula D event, Formula Drift, and stuff like that. Just trying to, learn something new. Because we want to learn just as much as y'all do. But I say thank you, and I'll turn you over to Champ.
Yeah. I always echo um what Nick was saying here. I think I had a little bit of an overwhelming time with school coming back into it, and kind of it is a little bit tough because I'm learning so much, and it's so much that you got to digest and debrief and decompress on. It's tough. So you always got to think about, what you can do and what's your limit is, because at the end of the day, you only get one life and you should enjoy it. So there's no need to kind of force yourself into a box. But if you have something like STEM, like additive, that you think is fun, then what's the use in not trying to make the most out of it? So we appreciate everybody listening. It's something that, like, we we never thought would even happen to this extent. So I think that you guys are the most valuable ones here. So I'm very appreciative to that. If I say anything that sticks with you, it's you got to continue learning. I've forgotten more things than I care to mention, but that just means I get to learn it again. So I think at the end of the day, you try to cement that knowledge, and you try to build upon what you've been given and what you've made already. So that's all you can ask, and you just be the best self. And at the end of the day, you should stay tuned to this if it's interesting to you, and reach out to us if you want anything, or want to chat about anything. If you're curious about school and you think that you couldn't do it before, you wanna ask some questions, how I was able to do it, or how Nick was able to, reach out to us. It's something that we're doing full time at the same time as we're in school, so it's a lot of time devoted to kind of bettering ourselves, and we think that you should do the same. So not necessarily that you have to go to school, but better yourself. you know. But yeah, no, stay tuned. There's a lot of good stuff coming. STEM Motorsports is something that's or Vulcanar Motorsports is something that Nick's really been really excited about. To be honest with you, it's been kind of his baby. So especially with the STEM or not STEM, the SEMA introduction and event that he went to. So stay tuned for a lot of good stuff coming there. And yeah, until next time.
All right, y'all.
Thanks,
Get out
guys.
there and learn something.
That's all for this episode of Tech at Lunch. Thanks for tuning in and joining us for this tech-filled lunch break. We hope you enjoy the show, and don't forget to subscribe on all channels. And also, you can find us on YouTube under Vulcanar Technology Solutions. And join us for our next episode, which gets published every Wednesday at 8 a.m. All right, y'all. Have a good one. See you later.